Hello and welcome to the day 12 of our Smart 25 Days challenge. And today we would be making our prediction marketplace smart contract. This is a smart contract where we would be allowing some people to participate and predict on the outcome of a future event. And after that, based on the result, we would be awarding the winners. So this is some kind of you can think of this as a betting website kind of thing, and we would be making a smart contract so that the things can be done securely and to increase the trust. So let us start building it. So let's just create a file called as prediction marketplace dot solve. Okay, so let's start making our smart contract. So what we are going to do is we would be following the same procedure as we are doing it. So first of all, we would be declaring the state variables. Then we would be creating the required functions, and the required functions here are basically two main functions, which would be one would be to allow the users to bet, and the other would be to withdraw their or to distribute the prizes. Okay. So let's start. So first of all, just uh, write down contract prediction marketplace. Okay, so let's start building it. So the state variables are, first of all, we need the owner of this smart contract, owner. Then we need a minimum bet amount. Okay, you public minimum bet amount. Okay, and then we need, okay, you, and then we need to make sure two things. So we would be tracking how much the how much amount of ether the users have betted on, say, the outcome one, and the users have betted on the outcome two. So we would be creating for them also, we would be creating two state variables called as total bets one and total bets two, so that it would be easier for us to keep a track on the amount of bet, the bet amount uh, for each outcome. Okay, so how much the user have betted on the outcome first to be true and for second to be true. Okay, so and then we need to keep track of the players. So we would be making an array of addresses public called as players, and then we also need a boolean flag to make sure whether the funds have been distributed or not. So I'll be using all these state variables, and then it would be more clear what I am trying to say here. Distributed. So these are all the state variables. Okay. So now let us start defining the functions, and first of all we need to make sure that for each player we need to keep track of two things. First of all, the first thing would be the amount which he would be betting, and the second thing would be his outcome, like what he has made the prediction, his prediction. Okay, so he has betted on whether the first or the second one. So for that we would be creating a struct of player called as player, and in this struct the two properties would be, first of all, amount bet, and the other second one would be the prediction. Okay, keep it in small only, prediction. Okay, so looks cool. And now what we are going to do is we are going to create a mapping which will be associating the addresses with these player structs. So to make it easier for us to access them, we are creating this mapping. Okay, so if you don't know what mapping is, please go through my previous videos, and I have covered all these things in detail. So please go through my previous videos. Otherwise, you can keep following. And so here we have created a mapping called as player info. Okay, so this is a public mapping. Okay, so that looks fine. So now let us proceed. And the first thing which we need to make sure is that we want to make a constructor. And what is a constructor? I have told you again and again, this is a special type of function which gets executed only while the deployment of the smart contract. Okay, so we want to make sure to assign the minimum, okay, minimum bet amount and minimum bet in ether. So and the owner would be the person who would be deploying this smart contract message dot sender. And the minimum bet amount, we would be setting that to minimum bet in ether into 1 ether. Okay, looks cool. So we are taking the bet amount in ethers. So now let's start creating our functions. So our first function would be bet, called to enable the users to bet, and this function would be taking prediction from the user prediction, and it is a public function, and it's payables. That means that it can receive ethers. So now let's uh, make sure that first of all we need to make sure that the required conditions are being fulfilled, and we are keeping those checks, and these checks will include that the message dot value should be greater than the minimum bet. Okay, minimum bet amount. Otherwise we'll say that the minimum bet amount not met. Okay, looks cool. And another check, we want to make sure that the prediction which we receive is either one or two only and not other than that. So that should be either one, or prediction should be equals to either two. Otherwise we'll say that it is invalid prediction. Invalid prediction. Okay, so looks cool. And after we have done with the required checks, what we are going to do is we are going to access the player info mapping, and in that mapping, with the use of message dot sender as the key, as address is the key, and then we would be accessing amount bet, this amount bet in the player struct, and then assigning the value message dot value. Okay, similarly, player info message dot sender dot prediction, setting the value to the prediction property, and the value is prediction. So basically what is happening here is we have combined two steps. Either the one approach could have been that first we would have created a player struct. Okay, so this struct, okay, a player type struct, and then we would have assigned these values into that struct, into these properties, and then we have we have uh, associated that struct with the player info mapping. But what we have done here is, what we have done here is in the single step, what we are doing here is by using the player info mapping and by using the message dot sender as the key. Okay, so we are accessing, by using the key, we are accessing the player struct. Okay, and that player struct, because by default it would be assigned with default values, and when we have retrieved this player struct, what we are doing after that is by we are using this dot operator to access the amount bet. okay, amount bet property of the player struct, and then we are assigning the value message dot value into this player struct. So to make it very clear, in two steps, what we could have done is we could have either created a player struct called as let's say new player, and called as mm, type player, and then we would have assigned the amount bet. Okay, yes, amount bet message dot value, and the prediction to be prediction. And after that we would have done what would have done, player info message dot sender equals new player. So see, instead of these two lines, we could have also done it in this manner to make it more clear. But for the ease of access, what we have done in two steps, what we are doing here, we have done it in a single step. And we are first of all creating a player struct, okay, called as a new player. And in that struct, we are assigning the values, okay. And then the what we are doing, we are associating that struct in the player info mapping. As you can see, this player info mapping, this accepts the key as an address, and the value type is the player struct. And then we are associating the in the player info mapping, we are associating this message dot sender with the new player struct. Okay, so I hope I'm very clear, but if still if you guys have any doubts, then please ask me out in the comment section. So we would not be doing it in this manner. This is just for your understanding. We will stick with this one only. Okay. So this is here done. And after that, what we want to make sure is in this bet function, we want to make sure that the total amount of bets gets increased. Okay. So uh, if the prediction is 1, then the total bets 1 should increase by message dot value. And otherwise, else if the prediction would be 2, so the total bets on 2 should increase by message dot value. Message dot value looks fine. And after this, what we are going to do is we are going to push the address into the players array message dot sender. Okay, okay, so and looks like our function is complete. So that's it with the bet function, guys. So now let us move on to the distribute prices function. And this function will take winning prediction public table message dot sender to be the owner, and only owner, otherwise you can say only owner can own this function. Another required condition would be that the winning prediction should only be either 1 or 2. This one condition only. So prediction should be 1 or winning prediction should be 2. Otherwise, we'll say that it's an invalid prediction. Okay. So that's it with the required conditions, and we also want to make sure that the total bets on winning prediction. Okay, winning prediction. Want to set that yeah, using a conditional statement. Winning prediction double equals to 1 total. So otherwise, or it should be total bets too. And then we want to make sure that there is some total bets on winning should prediction should be greater than 0. So there are some bets on this. Otherwise, we will say no bets placed on the winning prediction. Winning prediction. And then we make sure that the total bet is total bets 1 plus 2. Okay, and unit reward ether, we want to estimate the reward per ether, and that total. Okay. So let me first explain what is happening till now. So what we are going to do here is that we want to make sure that the total bets on the winning prediction are greater than 0. That means that the amount of ether bet on the winning prediction is greater than 0. That means that some bets are there on the winning prediction. Otherwise, we will say that no bets are placed on the winning prediction. And what we are doing here is this is a conditional statement, and what it's doing here is that it is say this unit total bets on winning prediction. This variable is being assigned the value of either total bets 1 if the winning prediction is 1. Okay, so this is a statement, a conditional statement, which have three parts. First one is the condition. This is the condition. Okay, so winning prediction double equals to 0, double equals to 1, sorry. So winning prediction double equals to 1, it means that if the winning prediction is equals to 1. Okay, so the winning prediction provided here is equals to 1. Then you move on to the first part. This is the case when the condition is true. This is the conditional part, this one. Okay, this is the conditional part, and this is the part if it's true and otherwise, or it's false. So what it means is if the winning prediction is 1, then you set the value of this variable total bet on winning prediction to be total bets 1. Otherwise, what you do, you set the value of total bets. Okay, so I have missed this S here, but no problem. So total bet to be the value of the total bets on winning prediction. Okay. I hope I'm very much clear. So this is the conditional statement, and after that we are making sure that okay, the total bets on the winning prediction are greater than zero. That means there are some bets on this winning prediction, and then we are what we are doing is we are calculating the total bet. So total bet means the total bets on one and total bets on two. And then after that, what we are doing here is we are calculating the reward per ether, because what will happen here is it means that the guys who would be the winners will get the rewards according to their bets. Say if some guy staked 2 ETH and the other guy staked 5 ETH, so and they both lie on the winning side, so they both should not get equal amount of return. Okay, so they both should get the return based on their staking amount. So the guy who staked 5 ETH should get more return, and the guy who staked 2 each should get some less return. So that's what we are doing here is we are calculating the reward per ether. Okay, so based on the reward, based on his number of eats he or she staked or betted on the particular outcome, the reward would be calculated. So that's it for this, and now what we are going to do is we will run a for loop to check whether the players who have made the correct prediction. Okay, so I less than players dot length and I plus plus. This is simple for loop, and address. I skipped the semicolon here. Okay, so I need to address player address. Let's call this player address and retrieve the value from players array. So what we are doing here is we are retrieving from the players array. This players array consists of the addresses, and the value stored at ith index. We are storing that into the player address. Why we are doing so? So that we can access the so that we can access this player info mapping, and because to access this mapping we need an address as a key, and so that we can access the particular struct player struct associated with a particular address. So that's why we are retrieving the player address from the players array. So player memory, let's call this way as player, okay, variable as player, and then player info player address. Okay, looks fine. So now what we have done here is we have created a local struct of player type, okay, player data type, and of course we have called that player so that we can access the values and check. Okay, so which values we are checking? We are checking the struct associated with a particular player address. Okay, and player address we have retrieved from the players array, and by using that address as the key for the player info mapping. Okay, so we have retrieved the particular player struct associated with a particular address, and then stored that player struct into the variable called as player so that we can access its properties easily. And then we would check that if the player dot prediction, okay, the prediction property matches the winning prediction, then we would be rewarding him. Prediction double equals to winning prediction. Okay, so then see a line. Then we would be rewarding him, and how we would be rewarding him is we would be calculating the reward equals to player dot amount bet, player dot amount bet, and multiplied by reward per ether. Okay, and then we would be paying that. We would be transferring the funds. Player address dot transfer reward. Okay, looks fine. And after this for loop has executed, we will set the funds distributed to be true. Make sure that the funds have been distributed. Yes. Okay. So looks cool. And now we would be moving on to our okay, looks cool. So we would be moving on to our another function called as function to retrieve the remaining funds. And which remaining funds? I'll explain it to you while demonstrating this contract. Okay. Public. So what in this approach, what I have followed is uh, as a platform, we should also take some fees. Okay, so if the users are using our platform and they are getting their funds, their winning amounts successfully and securely, so we should also get some stake in their winning, and we should also get some amount to because why are we, what's the whole point of making this a website kind of thing, or we making an application? Okay, so you also want to have some stake. Okay, so that's why what we are doing here is we are following an approach which will make sure that we also get some funds. And how we are doing that is, I'll explain it to you just after some time. First, let me complete this function. Only the funds should not be have been distributed. Okay, otherwise we'll say that funds not distributed yet. And the message sender should be the owner only. Only owner can retrieve the remaining funds. Another required condition should be that the balance of the smart contract should be greater than zero. This balance should be greater than zero. We say that no remaining funds. And after the checks, we allow the transfer of funds. So our retrieve remaining funds function is also complete. And then let's move on to our last function, that would be to reset this whole game. Okay, function reset. Okay, so we'll make sure that the funds have been distributed. So let's just copy this only. And we want to make sure that only the owner is calling. We could have also made a modifier called as only owner, but okay, yeah, it's fine. So that we may not have to use this required condition again and again. But that's it. And you want to make sure that there are no funds remaining in this smart contract. When it goes to zero, some funds are remaining in the contract. Okay. And If all these required conditions get passed, then we will be resetting that. Once distributed to be false, total bets 1 to 0, so that the platform can be used again for other betting. Yes. And you create a new array because we are using the new keyword to create a dynamic array, so we need to provide an initial size, and let's provide the initial size as 0 only. So that means we have created an empty array using the new keyword, and that's all for this smart contract, guys. Let's now demonstrate it. Okay, so we have successfully compiled it. So let's say the minimum bet in ether to be 2. Let's deploy it. So now say this user wants to place a bet, okay, and he wants to place the amount 4 ETH, and the predictions say he selects first. And so now you can check the total bets on one to be 4 ETH, and still now total bets on 2 is 0. So say some other user comes and he tries to place a bet on the say of value 2 on second. So let me just check what happened. Minimum bet amount not met. Okay. So yes, so there I have forgot to include the equal to sign. So that means that the minimum the message dot value should be greater than the minimum bet amount. So let us say he tries with 3 ETH. Okay. So yes. So now you can check. Okay. So similarly, say the game goes on and some other user comes and he places a bet, and this goes on and on. So after some time, what will happen is, okay, it's 3. Okay, so you can check. Okay, so both of them you can check total bets on first and second and on. So on. This goes on, and say what happens after some times the results arrive, and while the results when the results will arrive, so we want to make sure that only the owner should be able to call the winning prediction. Okay, so we have made that check. So say if some other guy uh, tries to use this, he or she would not be able to use it, and only the owner can call this function. So he will decide that whether the actual result have arrived or not. So till then, other users can participate, and they can just make keep on betting and all. Okay, till the time the competition is going on. So and some other guy also participated and all. So you can see the amount will be increasing accordingly. So what will happen now after some time, the owner decides to let us now distribute the prizes, and let us say the winner was first or second, anyone on, and say let us say the winner was first one or say second one. Okay, let's distribute the prizes and we'll see something. Okay, so let's do it 1, 2, 3. Okay, so you can see some users have received. Okay, so those who won this competition have received some funding. So, but there is one catch here. There is some balance. Okay, balance of 1 each. And why is it there? So this is the model by which we would be earning, or by which our platform would be generating some revenue. So what we have done here is, while calculating the reward per ether, what we have done here is, so there will be rounding off. Okay, so the total bets and the reward per ether is calculated by dividing the total bet by total bet on winning prediction. So there can be some rounding off. Say in our case, what was the thing? Okay. So in our case, what was the case? Total bets on first was 19 and the other one was 9. So what this means is that the total bet were actually 28, and those 28 got divided by what? Total bet on winning prediction, and we declared second one as the winning prediction. So what happened? So we divided it, and what happened while dividing 28 by 9? So the output which came to be was actually 3. And then what happened is, so actually this why 3? Because the actual answer would have been 3.11 or something. But because there would be some rounding off, because this is a year of UN type, so Solidity compiler or Solidity will just round it off to 3. And then accordingly, all the winners got their prizes. And because there was some rounding off, there we received something as a balance. Otherwise, if there would have been no rounding off, say that was 27 divided by 3, 27 divided by 9, and it was actually just okay, the exact number would have been 3. And so in that case, we would have not received any balance. And when we would have not received any balance, so in that case, we would have not earned something from this platform. But now we, as a owner, can get something back. And I'll just click on retrieve the remaining funds, and the funds would get transferred to the owner's account, and then he or she can just reset this smart contract and can see all the values will get reset. So that's all, guys. If you have some better implementation than this, or if you guys know that there can be some better implementation, or I would suggest you to try it out and to make some changes in it, and to have some other ways of earning through this smart contract. Or maybe if you don't want to earn at all, you want to say that I don't want to have any balance and I want to make sure that the fractional part is also there, so you can try that out also. And you can change the reward per ether in such a way so that there is nothing left. And so try to do it in that way, and I would suggest you to try it out on your own. I hope you learned something from this smart contract, and we'll meet on the day 13. Okay, bye bye.